Hello everyone! In this video, we'll introduce the concepts of classes and objects in Java. One of the main characteristics of Java is that it is an object-oriented language, that is class-based. Object-oriented programming, or OOP, is a whole topic on its own, covering concepts like objects and classes, encapsulation, polymorphism, among others. We will introduce some of these OOP concepts as we go along in this course and in more advanced courses. For the purpose of this video, let's focus on one of the main ideas behind OOP. That is, modeling our system as objects that have both data and behavior. Classes are the blueprints or definitions from where these objects are created. For example, let's consider an airplane. We can have a blueprint that defines how an airplane should be constructed and its different components. This blueprint represents our class in Java. In object-oriented terms, we want to identify the state or data of an airplane in our system and also identify the behaviors of an airplane that are relevant to our system. For the purpose of this example, let's assume that we want each airplane to have an identifier and a flag to indicate if the plane has landed or not. In terms of the behaviors, we want our airplane to have two behaviors. It can take off and it can land. And once we create actual airplanes from that blueprint, these become objects or instances of that airplane class that our blueprint represents. Now, we want these data and behaviors to be part of all the airplanes in our system. Hence, we can define a Java class for this purpose. This way, every object will have its own state and its own behaviors independent from each other. This means that instance 1 can have a different ID from instance n, for example. So, let's create our first Java class in IntelliJ. I have a started project with a main class and a main method to start with. To create a class in the project window, you can right-click on the package where your main class is. In my example, it's going to be io.jcoder.starter and select New Java Class. Now, you're going to get a small pop-up here. Here, make sure that the class option is selected, and in the text box, we're going to input the name of our class. In our case, Airplane. Please note that classes by design should represent nouns, like in our case, airplane. And in Java, by convention, the names of classes should be Pascal cased. This means that the first letter of each word should be capitalized. For example, if we have a two-word class like a commercial airplane, it should be defined like this. Anyway, let's type airplane and press enter. Excellent, now we have a new class in our system and it is inside the same package as our main class. However, right now this is an empty class, it has no state and it defines no behaviors. Let's add our state first. In our case we want two values, an identifier or ID and a flag to identify if the plane has landed. In Java we define state as variables inside our class. These are called fields. So let's add two variables that represent the state that we defined. So we type private int ID and a semicolon to indicate the end of the statement and private boolean landed. Let's explain a bit what we're doing here. We declared two fields inside our class. These values have different data types. In our case, we want the ID to be an integer number and we want our landed variable to be a boolean. Boolean values in Java can only take two values, either true or false, which is exactly what we want for this specific state. We added private to both. This is called an access modifier, which we will cover in more detail in later courses. For the purpose of this course, bear in mind that private will ensure that these values can only be accessed from the airplane class. It is good practice to reduce the visibility of the state in a class. This relates to the encapsulation concept in object-oriented programming. Alternatively, we could have used public in, for example, but this means that these variables can be accessed by anyone outside the airplane class. This is in general a bad practice. An extra note, if a variable is composed of two or more words, by convention, this should be camel-cased in Java. Same applies to methods. For example, if we had a flag to denote if the landing gear is deployed, we could call it private boolean gear deployed. Hence, the first letter of our second word is capitalized. Another thing to keep in mind is that when variables are declared as fields, like in the case of our two variables, Java will assign them default values. For numeric primitives, it will assign them a value of 0 by default. So private int id is equivalent to private int id equals 0. For Boolean primitives, it will assign them a value of false. So our statement private Boolean landed is equivalent to private Boolean landed equal false. Excellent. Now let's add our two behaviors. Behaviors should be verbs as they represent actions that our object can perform. These behaviors in Java are represented as methods in our class. So let's add the first of these behaviors. We will define a method called takeoff. And we're going to do it like this. Public void takeoff. We open and close parentheses. And then we open the braces that indicate the body of our method. Now, inside the body of our method, we will change the value of our landed flag. In our case, of course, if the plane has taken off, our landed flag should be set to false. So we do landed equals false. As you can see, inside the methods of our class, we can access the fields or variables that are part of the class as well. Now, we are not going to add any complex logic to our airplane class, as this is a basic example. So all I'm going to do is I'm going to add the other method to our class following the same pattern. In the case of the land method, I want to change the value of our landed variable to true. So let's stop again to explain a bit what we did. We declared two public methods in our airplane class. Remember that public methods can be accessed from other parts of our code. Again, this is something that we will cover in more detail in later videos. Both methods declare void as the return type. This means that they don't return any value. We will give some examples of methods that do return values later on. And finally, both methods have no input parameters. You see that inside the parentheses we don't have anything at the moment. In contrast, remember that the main method that we had in our main class receives an array of strings. In our case, we don't receive any parameters for this example, and this is valid in Java. Methods can declare no inputs. Okay, now that we have our class with the fields and methods that we wanted, it means that we have our blueprint. However, we haven't created any objects yet, and we haven't really used our airplane class. This means that if we run our application using the main method in our main class, we now have an airplane class, but at no point we have created objects or instances of that class. So let's change that. Let's start making use of our new class inside our main method. To create objects in Java, we need to use what is called a constructor. The most common way to do this is using the new operator. We will cover constructors in more detail later on, but at the moment just follow along with the example we're providing. In our example, all we need to do is to define a variable of type airplane, and we use the new operator. So let's call our first variable plane1. So we're going to type airplane plane1 equals new airplane. Now, there are three main actions taking place in this line of code. First of all, we are creating an airplane object as such. This is the new airplane part. Second, we are declaring a new variable of type airplane that we called plane1. And third, we are assigning the plane1, so our variable, to point to our newly created airplane object. So did I say point to the object? Yes, that's what I said. And to explain what I mean by this, first, note that our plane1 variable is not a primitive type, like int or boolean. The type of our plane1 variable is a class, in this case, airplane. All non-primitive types are called reference types in Java, and it is very important to understand the difference between an object and a reference to an object. Let's visualize this to help clarify these two terms. Our plane1 variable, as any other variable, has its own space in memory. It stores a reference to an object. As such, plane1 is a reference to an object. When we execute new airplane in our code, Java reserves memory and actually creates an airplane object. But note that this is separate to our plane1 variable. It's a different place in memory. When we assign plane1 to be equal to new airplane, what happens internally is that plane1 becomes a reference to that new airplane that we created. So imagine an arrow between the plane1 and the airplane object that was created. Let's add a couple of objects more to visualize this even further. Let's create a plane2 and plane3 variables, both of type airplane. And now let's do the following. We're going to set plane2 to be equals to plane1, and we're going to set plane3 to be equals to a new airplane. In this case, we have 3 references to objects, which are variables, plane1, plane2, and plane3, but we only have 2 airplane objects in memory. These are easy to identify as we have the new operator. We are only calling the constructor twice with the new operator. Hence, we only have 2 airplane objects in memory. So let's visualize this again. In this case, we have 3 references, which I'm going to draw on the left-hand side. But we only created 2 objects using the new airplane expression. So for plane1 and plane3, we already saw what happens in the previous example. We saw that they point to the new airplane object created in the respective lines of code. However, what happens when we do plane2 equals plane1? In this case, plane2 will reference the same object that is currently being referenced by the plane1 variable. So imagine a second reference line that is pointing towards our first airplane object. Even if later plane1 stops referencing our first airplane object, plane2 will continue referencing that object until we assign a different value to the plane2 variable. Now, the last thing I want to show you in this video is how to make use of these airplane objects that we just created. We can access object members like fields and methods using the dot operator in Java. So, for example, let's assume we want the first airplane we created to take off. In this case, we can do plane1 dot takeoff. That's the dot operator over there. As the takeoff method has no input parameters, we don't need to include anything between the parentheses. In IntelliJ, once you type the dot after an object, it will display the different fields and methods that are accessible. In our case, you will see that the takeoff and land methods are in the list, but the ID and the landed fields that we declared aren't there. This is because we marked them as private. You will see other methods in that list that we didn't define. These are methods that are available to all objects in Java. Okay, as you can see, we can change the state of our airplane objects. We can ask them to take off and we can ask them to land. But there is currently no way for other classes to see if the plane has landed or not. So let's add a new method in our airplane class that will return true if the plane has landed or not. So let's add public boolean has landed, and inside the body we're going to add return landed. You will see that in this case our method is expected to return a boolean value. Instead of using void like we did before, this time we used boolean. We're telling Java that when we call this method, it should return a value. And because Java is a strongly typed language, we're telling it that it will return a value of type boolean. To return a value from a method, we use the return keyword, and after that keyword we just put the value that we want to return. In our case, we want to return the value of our landed variable. Now, from our main method, let's print if our first airplane has landed or not. So to do this, we type system.out.println, and inside the parentheses, we type plane1 dot has landed. Basically here, we're invoking the method, or we're calling the method that we just created for our first airplane object. Excellent, now let's run our code and see what we got. In our case, our first airplane took off, so the has landed method will return false, which is the value that has been printed to the console. Now, as a final step, I want us to run the code in debug mode this time to see what is happening behind the scenes. So let's add 2 extra lines of code. Let's add plane2.land, and let's print again the same message as before. So print out the plane1.haslanded value. And let's add a breakpoint on that last line. And we're going to run the code in debug mode now. There are 2 things that I want you to see in this case. First of all, in the debugger window, you can inspect objects and we can see their internal state. Even if the state is declared as private, for debugging purposes, we can see all the variables in the objects. Second, when we executed the plane2.land line of code, the landed flag of that object was set to true. And we can see that in the debugger. However, remember that plane1 and plane2 are referencing or are pointing to the same object. So if I inspect the landed value of plane 1, it will also be true because it's the same object behind the scenes. Now, if we check the landed value in plane 3, it has a value of false. Remember that plane 3 references a different object, and we haven't called the land method on that airplane object in our code. Okay, so a lot of content covered in this video and plenty of very important concepts. To recap, in this video we covered an introduction to the concept of classes and the difference and relationship between a class and an object, the definition of a state and behavior inside a class by using fields and methods, and the difference between an object and an object reference. We also talked about how to access or invoke a method of an object using the dot operator, and also introduced the return keyword to have methods that return values from our objects. Finally, we saw the basics about how to debug code when we're using objects. We still need to introduce more concepts that come to play when designing classes. However, for an introductory video, we covered several details, and this should give you a good overview of classes and objects in Java. And that's it for this video. We hope you found it useful. Thanks for watching, everyone.